What specific problem does WINDOWSAGENTARENA aim to solve in the context of evaluating multimodal agents?
WINDOWSAGENTARENA aims to address the gap between the complexity of realistic human workflows and the limitations of existing agent benchmarks, particularly those focused on Linux environments like OS World. By creating a benchmark suite specifically for the Windows OS, which holds a 73% market share among users, it provides a more relevant testing ground for multimodal agents. The benchmark features 154 diverse and realistic multi-step tasks that reflect typical user workloads across various applications, allowing for a more accurate evaluation of agent performance. Additionally, WINDOWSAGENTARENA enhances evaluation efficiency through task parallelization in a cloud environment, significantly reducing evaluation time from potentially days to as little as 20 minutes. This approach not only improves the scalability of evaluations, but also facilitates faster experimentation and data generation for future agent development.
How does the proposed WINDOWSAGENTARENA method work? Illustrate the steps involved in its implementation, including how tasks are structured and evaluated.
The WINDOWSAGENTARENA method operates by providing a benchmark suite specifically designed for testing multimodal agents within the Windows OS environment. It consists of 154 diverse tasks that simulate typical user workloads, such as document editing and web browsing, structured in JSON configuration files that include natural language instructions, initial setup steps, and evaluation criteria. Each task is executed within a Docker container hosting a Windows 11 virtual machine, where a client process manages task scheduling and evaluation. The evaluation of task completion is conducted through post-processing scripts that assess the agent's output against predefined criteria, returning a reward based on the accuracy of the task completion. Additionally, the system allows for cloud parallelization via Azure, enabling efficient execution of multiple tasks simultaneously, significantly reducing evaluation time compared to traditional sequential methods.
Can you walk through a specific task from WINDOWSAGENTARENA and illustrate how the agent Navi would approach completing it step by step?
One specific task from WINDOWSAGENTARENA involves editing a document in LibreOffice Writer, where the agent Navi is instructed to make the line spacing of the first two paragraphs into double-line spacing. To begin, Navi receives the task instruction along with the current state of the system, which includes the title of the active window and the content of the clipboard. The agent first sets up the initial state by opening the required document and ensuring it is ready for editing. Next, Navi processes the screen representation using a combination of UI automation, UIA, tree parsing, and pixel-based segmentation to identify the relevant UI elements, such as the paragraph settings in the toolbar. After understanding the current layout, Navi generates a sequence of executable actions, such as navigating to the paragraph settings and selecting the double-line spacing option. Finally, the agent executes these actions, evaluates the outcome by checking the document's formatting, and confirms task completion by comparing the modified document against a gold standard file. This structured approach allows Navi to effectively complete the task while adapting to the dynamic environment of the Windows OS.
What are the main advantages of using WINDOWSAGENTARENA compared to previous benchmarks like OS World, particularly in terms of task complexity and evaluation speed?
WINDOWSAGENTARENA offers significant advantages over previous benchmarks like OS World, particularly in task complexity and evaluation speed. Firstly, it introduces a diverse set of 154 realistic multi-step tasks specifically designed for the Windows OS, which better reflects the typical user workloads compared to OS World's Linux-focused tasks. This alignment with real-world applications enhances the complexity of the tasks, allowing for a more accurate assessment of agent capabilities. Secondly, WINDOWSAGENTARENA employs a cloud-based parallelization approach that allows evaluations to be completed in as little as 20 minutes, compared to the multiple hours or even days required for serial computation in OS World. This scalability in evaluation speed is crucial for efficient experimentation and development of multimodal agents.
How is the effectiveness of the WINDOWSAGENTARENA benchmark validated, and what datasets or metrics were utilized to demonstrate its performance?
The effectiveness of the WINDOWSAGENTARENA benchmark is validated through a comprehensive evaluation of a newly developed multi-modal agent, Navi, which operates within the Windows OS environment. The benchmark consists of 154 diverse tasks that reflect typical user workloads, and human performance on these tasks achieved a success rate of 74.5%. To assess Navi's performance, various configurations were tested, with the best configuration yielding a success rate of 19.5%, indicating a significant gap compared to human performance. The evaluation metrics include task completion rates and comparisons of agent performance across different task categories, highlighting strengths in text-dominant interfaces and weaknesses in tasks requiring keyboard shortcuts. Additionally, the benchmark's scalability and efficiency are demonstrated through its ability to parallelize evaluations in Azure, reducing evaluation time to as little as 20 minutes, which is a substantial improvement over traditional methods.
What limitations or challenges does WINDOWSAGENTARENA face in evaluating agents, and what future enhancements do the authors suggest to overcome these issues?
WINDOWSAGENTARENA faces several limitations in evaluating agents, primarily related to the time required for task completion due to the sequential nature of multi-step tasks, which can take days to evaluate on local machines. The authors address this by implementing cloud parallelization, allowing evaluations to be completed in as little as 20 minutes, but they acknowledge that the complexity of tasks and the need for precise set of marks, SOMs, can still hinder performance. Additionally, they note that visual language misalignment often leads to failures, as agents struggle to align their text outputs with visual inputs. To enhance the evaluation process, the authors suggest future work could include modifying the reward system to allow for intermediate non-zero rewards for partial task completion, which could provide more nuanced feedback during evaluations. They also plan to continuously update WINDOWSAGENTARENA with new tasks and capabilities to improve agentic testing and evaluations.